Alright, on today's episode of Python Papi, we're back inside our Tensorflow course and we're still doing our human emotions detection module. Let's have a look at what we went over today. And we're still in our resonant module, so let's have a look at what we went over. And today we're going to be going over understanding why we need the residual block. So let's pick up with some light reading. Now let's get a better understanding as to why we need the residual block. We need to first understand why models, which are based on just stacking up carved layers like the VGG, actually underfit even when we increase the number of layers. The reason for that is exploding and vanishing gradients. Let's explain what it means for gradients to vanish. Recall that in the gradient descent process, we have a weight. This weight is updated in such a way that we take its previous value minus the learning rate times the partial derivative of the loss with respect to the given weight. That equation will look like this. You can see here we have a weight equals the weight with the previous value, take away the learning rate, and we're going to multiply that by the loss with respects to the weight. Move down some. Now, during the training process, in order to compute this partial derivative very efficiently, is we would use a method called backpropagation. The way that backpropagation works is that we have a model. Let's say, for example, we call it M. Then we will say that the model M has an input and an output. That will look something like this. So we have our input going into our model M here. We have our output. Now, let's say we name our outputs. We're going to call our outputs Y and Y cap. Let's go down some more. We'll say that Y is what the model expected and Y cap is what was predicted. It's the difference between these two outputs that produces the loss. And we're finding a partial derivative of this difference with respect to every weight which makes up the model. Then if we were to split the model up into different layers, we would note that each layer is composed of several weights. So let me show you what that looks like exactly instead of doing more reading. So this is our model here. As you can see, it's the same as doing above. I have the input, then we have our model, then we have our output. As you can see, I have these little bars here indicating that we split up the model into different segments, and each segment has its own weights. Now, to find the partial derivative of, let's say, any particular section of weights here, let's say this one here, we would have to actually go back to the previous sections before to multiply those to actually get the new weights here. So we'd have to actually go back before we can go forward. That's why it's called backpropagation. Now, basically, we did a bunch more of this. I'm not going to do a lot of reading because it is a lot to dive into. Of course, if you want to dive in yourself, you can, but that's basically what we did for the day. We went over the explanation of why backpropagation was needed and why we needed to actually have our residual block in the session or in use when we actually move forward because of how small the increases in the value were when we try to move forward, looking at our weights and the values of the weights. But of course, we will keep moving forward every step of the way, and I will keep you posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.